So this should be the next page in 3.1, just double checking, yep, it should be the next page. And what we'll be doing, so I'm not giving you the graph of this function. You should be able to figure out where the graph is below the x-axis, because that's what it means to be less than 0. And we're just going to use algebra skills, and notice the multiplicity. If -2, don't forget about the -3 in the numerator, and then +1. And as I mentioned in an earlier video, it might actually be helpful as you write out your table that we learned in the previous unit, that you also put, so it's okay for things in the numerator, x equals -3, to be 0 at -3, but when you're in the denominator, that's an undefined value. So these two are in the denominator, -2 and -2 with that multiplicity in the numerator, and then that one's also in the numerator, so it's okay to be 0. I kind of hesitate to say this, but it's kind of nice in this problem that it's less than 0, because we don't want any of these as our answers. So even if you do this chart wrong, you might still get the right answer. So as a reminder from previous lessons, to the left of your zeros are negative values, and then to the right of those zeros are going to be positive values. Just trying to color code it to really emphasize how to do this chart. And then you multiply straight down. Well, negative times negative times negative times negative. These 4 negatives comes out to be positive. Positive times negative times negative times negative is negative. 3 negatives. Here's another negative. And then 4 positives make it positive. So again, being below the x-axis means we want negative values. And we do not want to include, so -3 to -2. So parentheses is what I was trying to say there. And then from -2 to 1 is your final answer here. So we can look at the graph. Graph is right here. I think it's pretty evident when you look at -3, and to the right of that, it goes below. We cannot include -2 because that's a vertical asymptote. So even though it looks like it's below the x-axis, there's no defined value there, so it's not. And then from -2, and we're going to stop once we get to 1. I'm trying to put a parenthesis there, but that one didn't look like a parenthesis. And yeah, pause the video at any point too if you feel like you need some extra help. So we have a couple more. Let's do fun colors. My encouragement to you would be to factor if you can. The only thing is the denominator is not factorable, but you could use a quadratic formula to figure out x equals -b plus or minus the square root of b squared. 4 squared is 16, minus 4 times 1 times 2, which is 8, all over 2 times a. So 2 times 1 is 2. So we're looking at -4. I guess I could have identified in the numerator is x equals 3. And what I'm doing with the quadratic formula is the denominator. So looking at the denominator, just a little scratch work that's root 18, which breaks down as 4 and 2, 2 and 2. So that's 2 root 2. So the values I'm looking at are negative. I'm not going to write -4 because, well, let's just show that work. -4 plus or minus 2 root 2 over 2. That you can divide each piece by 2. So what I'm saying is that is the same thing as dividing by 2 to each term. This might help some of you understand. And 4 divided by 2 gives me -2. And then these 2's that cancel. So that is in the denominator. So those are undefined values. So as I make my chart, -2 minus root 2 is actually smaller than positive 3. But 3 is larger than, no it's not. I don't know what I was thinking. 3 is a positive number. So -2 plus root 2, and then 3. And I believe if I share the answer key with you, this person actually uses the decimal approximation, but we're better than that. We're not going to use the decimal approximation. So this is the value for -2 minus root 2, and then this is -2 plus root 2, and then here's 3. If it's in the denominator, it's an undefined value. So -2 minus root 2 is undefined. -2 plus root 2 is undefined, but this one is okay. Negatives to the left. Notice that there's also no multiplicity here. Positives to the right. So 3 negatives is negative. We don't want negatives because if you go back to the directions, we only want positives. Negative times negative is positive. 1 negative is negative. We don't want that. And then 3 positive is positive. So how do we write our answer? Well, we want greater than or equal to. Let me switch back to that other fun color. But we don't want to include -2 minus root 2 or -2 plus root 2. Why? Because that was denominators equaling 0, and those are undefined values. But we do want to include x equals 3, because that's the numerator. It equals 0 there, and going all the way to infinity. And sorry, I tried to squeeze it all right there. Did not give myself much room. That should be it. And you can double check with the graphing calculator, especially if we're having take-home tests. If we have take-home tests, then you can double check with the graphing calculator. All right. So if we look at the next one, it looks like -2 is the smallest. I'm going to just jump to the chart because it's already factored for us. It looks like -1/2 is another one, and then 3 happens twice. There we go. So we have -2, we have -1/2, and we have +3. So again, as I make my chart, I'm going to put undefined values when the denominator equals 0. The denominator was x equals -2. And then when the numerator equals 0, that's okay to equal 0. But it actually does not matter as you look at all my work, because we want to only be below the x-axis. We only want negatives, so we don't want where it equals 0. So as we fill out the chart, this is why I really emphasize this chart, because it's really easy to show your work when you understand the chart. And if you still don't understand the chart, please ask me in class your specific question, because right now I'm going to assume that everybody gets it. 5 negatives is negative, 3 negatives would be negative, 2 negatives would be positive, and then 5 positives would be positive. So we only want below the x-axis. Those are negative values. We don't want when they equal. So we're going from -infinity to -2, and then union from -2 to -1/2. All parentheses, and we should be good. Now we have one more hiccup in this lesson, and that hiccup is this type of problem, and my first step is actually very important. I'm going to leave that 3 over x plus 2 alone, and I'm going to subtract 2 over x minus 1 to the left side. And the reason why is I want to get it in relationship to 0. So you want to show, that doesn't always, WTS is not a normal math thing, this is a Mr. Higbee thing. You want to show a relationship to 0. So you don't have to do the problem my way. Some students might subtract 3 over x plus 2 to the right side, but then you would have 0 is less than or equal. I just like having 0 on the right side, so this is my preference, because this clearly shows me I want where the curve is negative. So let me put a little box around that. That's what I just showed by doing that. Well, now we have a lot more math to do. What do I mean? Is I need to get this as written as a single rational function. Well, how do we get a single rational function? Is we need to get the same denominator. Well, how do we get the same denominator? Is you multiply the denominators together by multiplying. So really what's happening is, in order to get the same denominator, let's go with orange, is I need to multiply this left fraction by x minus 1. Well, if I multiply the bottom by x minus 1, I have to multiply the top by x minus 1. So what I get there, so as everybody agree, I hope you agree, I should say, because you can't answer me, that multiplying these two together gives me this new denominator. In top, I get, when I distribute 3 to each term, I get 3x minus 3. Now be careful, be very careful with this other one. Pretty much the same color, but I need to multiply this bottom fraction by x plus 2. Is you need to be careful because you also need to distribute this minus and this 2 to each term. So I'm really going to have minus 2x minus 4 is still less than or equal to 0. Well, let me rewrite this. So just, this is me, this is my symbol for, let's look over here, because I can simplify 3x minus 2x is 1x. Negative 3 minus 4 is negative 7. And now it's just like the previous problems we've been working on. So I'll switch back to a brighter color where we have negative 2 for my sign chart, positive 1, positive 7, negative 2, 1, and 7. This is my number line, by the way. And without a calculator now, we can identify that undefined at negative 2. Remember, it's in the denominator, it's undefined. Undefined at 1. It can equal 7, because 7 minus 7 equals 0. That's okay for the numerator to equal 0. Negatives to the left. Positives to the right. 3 negatives is negative. That's what we want. 2 negatives is positive. We don't want that. 1 negative is negative. We want that. 3 positives is positive. We don't want that. And so what's our final answer? I'm going to write over here. Is negative infinity to negative 2. We do not want to include negative 2 because it's undefined. That was the denominator equaling 0. And then also from 1, but why do I need a bracket with 7? Is because it's okay to equal 0. And it's okay for the numerator to equal 0, not the denominator. So this is it. So pause the video if you need to really understand this. And you should be ready to start on the homework. So enjoy.